A common theme in undergraduate science is teaching students to think like or be a scientist. And this led me to introduce a research integrated learning stream into an advanced biochemistry course and to evaluate its effectiveness. The innovation provided 50 interested students from the course with a research experience instead of their traditional cookbook-style classes. I designed the curriculum to ensure that both streams shared a set of technical and non-technical skills, and I wrote assessment tasks that addressed the elements that were common to the two streams. The students in the research integrated stream carried out experiments in their weekly laboratory classes to look at a metabolic pathway in yeast and how it's regulated. Before each class, the methods were optimised on controls by the technical staff, but otherwise the results remained unknown to both the staff and the students until the lab was finished. And this aspect was key to the authenticity of the experience. I evaluated student learning using a post-survey. This comprised both students in the research stream and also those that were not in the research stream, in the traditional stream. The survey tool was an undergraduate research student self-assessment survey, which is really designed for internship-style research experiences, but was effective in this context also. It investigated skills acquisition, awareness of the practice of scientific research, and future plans. Questions on the theme of thinking and working like a scientist showed the research stream students reported the highest frequencies of good and great gains for displaying data in a scientific format and communicating the outcome of an experiment. When looking at professional identity, such as whether students have a sense of belonging and ownership of their research activities, there was a significant difference between the research students and the traditional cohort for the items engage in real-world science research, try out new ideas or procedures on your own, feel responsible for the project, and work extra hours on the project. The research stream students reported the highest percentage of gains for the items engage in real-world science research and feel like a scientist. When looking at personal gains related to research work and gains in skills, the research stream students reported significantly higher gains for understanding what everyday research work is like and keeping a detailed lab notebook, a practice that was encouraged but not assessed for them. No significant differences were reported between the groups of research and non-research students for interactions with their lecturer, their tutor, and their peers, both inside and outside of class. Of interest, the research stream students reported significantly higher gains for the item, "My research experience has prepared me for postgraduate research, including honours." This evaluation demonstrated the experience was successful, with learning gains suggesting students in the research group gained an increased confidence in their abilities as a scientist. The same met a desire from my school that students enter an honours or postgraduate year more prepared. Reflective responses or qualitative data from the research stream were analysed to give feedback on the course for further iterations. They focused on identifying the aspects that were either a help or hindrance, and from this 2/3 of students suggested an improvement, and some of these suggestions I implemented in subsequent years. These included more time for explanations and discussions. Over 1/3 of the students described gaining a personal benefit from the experience. They reported skills acquisition, including technical and non-technical skills, like using literature and writing a laboratory report. Many students, more than 50%, made comments related to experiencing real or authentic research and their appreciation for its challenges. It was only by evaluating this innovation, both qualitatively and quantitatively, that I was able to gain useful feedback for subsequent iterations, able to demonstrate its success, and get data that I could use successfully for promotion and teaching awards.